Hello, everyone. Welcome. Thank you for joining us this fine, hot afternoon in Southern California. The weather's begin to kick in. It's finally summer. And as part of that heat, of course, we are bringing to you as much knowledge as possible to pound into your head and get even more heat going inside of your body. So thank you so much for joining us. Our presenter today is the founder of Pegasus One. He's going to walk us through the S.O.N.G framework that he's showing you here, real production failure cases that he's come across, and a live AI adoption scorecard. He is Tushar Puri. He's a friend of mine. He's a partner of mine. And I know there's a bio that explains how he has over 21 years of hands-on experience with software solutions, all the way from small enterprises to Fortune 500 companies since like 2008, but that doesn't really describe the person that Tushar is. He's got a heart of gold. He's very invested in this chapter, and he wanted to make sure that he could bring to you, all of you here today, and those who might be watching on the recording, his perspective on exactly where AI implementations hit their barriers. So I'll be monitoring chat. If you have any questions, please feel free to either click the raise button right that. You'll see your hand raised and a big yellow hand there. I'll see that. Or you can drop your questions directly into chat and I'll make sure Tushar addresses them. So why don't I turn over the floor? Thank you so much. Welcome, Tushar Puri.
Thank you, Jason. That was a gracious introduction and always love your energy. I hope I can maintain the same or more of that. Let's see. So, good afternoon, everyone. My name is Tushar Puri. I'm CEO and founder of Pegasus One. So, I'm here to talk about not how good AI is. We all love AI. All of us have been dabbling with it in one way or the other. But there is, for good or bad of it, there is enough evidence out there which tells us there have been more failures than successes, especially when these products move from proof of concepts to production. So I'm here to talk about what the lessons we have learned, what we have seen in the industry, what we are seeing in the market. So the biggest lesson which we have seen is during proof of concept, the focus is mostly on accuracy of the model, how well outcomes are coming out, how accurate they are. However, a very important and critical part, which generally gets ignored in proof of concepts, is human experience. So our focus has just not been building AI, but building AI implementation, which actually fits into real workflows in the way teams work and the way decisions are made. Because we know at the end of the day, it's the human experience which is the measure of success, not just the technology. Other thing we see in proof of concepts is focus is generally on very clean and sanitized information. A lot of use cases are ignored. And I'm not saying that during proof of concept, we need to handle all the use cases, but at least we need to bake in the use cases. So once the system is in production, all the use cases flows seamlessly. So we have put together this framework we call as S.O.N.G, which measures success or lack of it for AI implementations when they go to production. So I'll give you a quick introduction of S.O.N.G framework. So starts with signals. So the goal here is to figure out, can the AI agents reliably get the data, the correct data, and at the right time? Second one is orchestration. Do the AI agent fit into the current workflows, or will it add to the work of the people who are going to be using it? Because that will either add or eliminate friction and trust as folks starts using it. Normalization, that's a big thing. Like in software world, we know we come across lot of information which semantically may mean same thing, but they come across in different shape and form. So as an example, in a claim system, one claim system might call final claim status as paid, whereas other can call it finalized. Both mean same thing. So, but they need to be normalized. So when AI systems work on it, they understand the semantics behind it. Other thing which we have come across is more prominent in multilingual systems. So one of our software was being used at a school system, and this kid wrote in Spanish, tomar el peo, which literal, in literal terms meant grab the hair, which was a connotation for a violent action. And this kid almost got into trouble. Whereas in Spanish, this phrase really means don't pull my leg. So those kind of aspects need to be also built in as part of data normalization aspect. Uh, Governance, we all know we need to be able to build system where we can track how the results are being produced, audit those results, and be able to explain those results. So with these four pillars, we look at our implementation and make sure these will survive in production. Moving on. So for unfortunately, I believe a lot of conversations which we have, they always go around savings on cost or adding new revenues. It's all about dollar and cents, which we understand as a business is, of course, a very important aspect for any business. However, you will not have ROI in terms of dollar and cents unless your system is adopted as part of the workflow. So people should be able to trust the outputs. It should be able to make their decision process better, faster, and more consistent. And not only that, just be able to amplify the decision, so they should be able to make better decision than how they were being made in the past before AI was implemented. So we feel adoption should be front and center since it's a leading indicator versus ROI, which will always come into picture as adoption increases. So these are the four scorecards which we typically use, starting with output volume all the way to uncertainty handling. So I'll explain each of these a little. So we built a system for a claim center automation where so output volume will be something as simple as how many calls this AI agent is handling on day by day basis. Adoption is also very critical, or probably more critical, just the volume from the volume part, because as an example, say a patient calls up the claim center and there is some discrepancy with the claim. If the AI agent is able to clearly explain the discrepancy in the claim and provide insights to the patient that what needs to be changed in the claim by the doctor, and and then patient is able to take it to the doctor to get it fixed. So that means the output of a agent has been adopted and accepted by the patient, and they were able to take the remedial step. Decision chain rate is also very vital. So as an example would be, uh, let's say a patient calls up a provider and asks for lab results, and AI agent is able to look at the lab results and they see it has not been received. So instead of just saying, hey, we have not received your lab results, it can go one step further and say, hey, we have not received your lab results as of yesterday evening, but it's likely we will get it into the feed of this evening. So you can check it tomorrow. So that essentially changes the decision for the patient. Instead of just saying it's not received, and then patient going into the spiral of calling the labs and trying to figure out why it has not received. Now the patient is more assured that it's likely it will come tomorrow. So that's the impact on decision change aspect. Override rate is, as it's obvious, if the decisions being made by agent are being overridden by human beings, that's a concern, and that's something which needs to be looked into. Uncertainty aspect and handling of uncertainty, to me, it's the most important thing. We know AI agents can very confidently give you wrong information and you will not even be aware of it. So we need to build agents which knows uh, what they do not know. So when they're providing outputs, they are providing with the qualifiers as to why it can be wrong or why it's not complete. So the person on the other side is aware of the caveats with the output they are receiving. So these are the four scorecards which we use to look at how well the adoption is happening, which will eventually turn into the ROI for the system. So during this webinar, we'll dive deeper into some of these design patterns, which will address different parts of the puzzle to make a system production ready and adapt to changing ecosystem around it. So I'll just give a brief intro of each of it. So severity gradient, essentially system being able to provide adaptive response based on persona of the user and also the context of the information. Breaker design pattern is all about fault tolerance. So as we know, agents behind the scene would be talking to several other, sorry, backend systems. So those AI agents needs to be aware of what's happening in the backend system, if there are any issues while reaching out to some databases or APIs, and instead of just retrying it, it should be made aware of those backend inconsistencies and be able to manage those gracefully. Independent checker is all about validating the outcomes which agents is producing. And so basically, there should be at least two agents. One agent, as an example, provides the outcome, and then the validation agent comes in and cross-checks the outcome before it goes to the user. Anchor reinjection, that's very important, especially in the queries which go through multiple steps, because and you would have seen it in chat GPTs and Claudes also, if you're asking sequentially a lot of questions, it sometimes tends to lose the main goal or the focus of what you're trying to achieve. So it's very important that as you go through those multiple steps, you're inserting the main goal or intent which you want your agent to achieve. Approval gate is slightly different or another layer of governance, I would say. So approval gate is not about agent doing something wrong, but preventing agent from doing something wrong before it happens. And I'll get into the nitty-gritties of that as we move forward. So severity gradient, I will put it in two different aspects. One is changing the output of the agent, not just based on the persona of the user, say, which you see, say, on Amazon.com, it behaves or provides you different insights based on your purchase history or browsing histories. That's persona based. Other one is context based. So based on the same user and the information it has today, it can change its outcome. And I'll give you the examples of both of those as we move ahead. So this is one of the example where agent is changing its behavior based on user's persona. So in this case, say a billing agent from a provider office calls the claim center to check on the status of a claim. And if there is a discrepancy in claim, agent can be very direct and succinct and say, okay, this CPT code is missing, it's likely to be rejected. I can send you an email with the details so you can resubmit it so it can go through. Whereas if, say, a new mom is calling the claim agent, she would need more detailed explanation and less uh, technically savvy information. So agent can say, okay, there is a problem with the way doctor has submitted the claim. I can email you the detail of what you need to take it back to the doctor so they can fix it and send it back. Similarly, if you have a frustrated or unhappy customer calling, agent needs to not only be able to understand and explain the problem, but also be more empathetic and be ready to listen to what this person is trying to achieve. So this is an example of more of context based, and we all use uh, apps where say exercise tracking apps, like Apple Health and so forth. So a lot of these apps will track your workout intensity over a period of day, over a period of week, or longer. So as an example, if your workout intensity on a given day is say only lagging by 5%, it can provide an outcome which can be more of celebratory outcome. Hey, you're only 5% behind and you can just knock it out by a short walk. Uh, if say you're behind by 25%, that should change the tone to be maybe more of encouraging tone and say, hey, maybe do a 20-minute walk and let's keep the pace consistent so you can knock it out. So it has to encourage the user to take some additional step and initiative to knock out today's intensity. And say if you have not worked out for last 3 days and you're behind 70, 80%, then it needs to change its modus operandi and come back with certain alternates. Hey, you have not worked out for last few days. Maybe I'll give you a schedule for today so you can start ramping up. So it needs to be now more supportive. So now we'll jump into a circuit breaker uh, design pattern. Here, the critical thing is, first of all, agent knowing what it doesn't have, be it the information, be it the insights, or if there is a delay in the data. So it needs to be aware of those aspects and then manage it accordingly. So it's all about building the awareness in your system. So when it's providing outcome, it's meaningful. So let's say, so one of the way it can be done is by building a latency aware system. So going back to the example I provided earlier, whereas if a doctor's office doesn't have the latest results, instead of just saying we don't have the latest result, it should tell the caller that results are not available today, but it can be available later. So now the person on the other side is more in tune with the reality rather than just reactive if the information is missing. So in the previous slide, we talked about data delay or data latency. And this is more focused around if data is altogether missing. So as an example, we all have seen systems where you click a button and you see a spinning wheel. In that case, likely the backend systems are trying to call to one or more APIs or trying to access some database and it's just not responding. Other case could be you're trying to reach out to the systems. Some of them are responding, some of them are not responding, but your agent is still providing output without bringing to the bringing forth the fact that it is built on incomplete data. And third one is even more critical, where systems are just calling the backend applications and building long queues, messing up the whole orchestration, and overall slows down the workflows, and it eventually shuts down. So how do we solve these problems? I'll give you some solutions for that. So back in the days, even now, when we have distributed systems in microservices-based systems, there would be these APIs or microservices which have to work in tandem, and not all the services will be available all the time. There could be delay, there could be unavailability. So we'll put it in three buckets, where closed situation is where all the services are functioning the way, more or less functioning the way they're supposed to be functioning. There could be slight delays in some backend responses, but then you just log it and move forward. The second state would be open, where similar to the spinner problem we talked about, that once failure has reached a threshold, then system stops reaching out to those failed APIs or system and provide output with an insight that it's based on partial insight it was able to receive. Third one being half open, whereby once it has stopped talking to a system, after a cool down period, it just sends a test request to see if the behind the scene system is up and running or not. And if it is not, then it continues to ignore it. And if it is, then it starts using it and goes back to the closed system. So this whole mechanism, there are three states with based on which uh, your backend tooling or plumbing needs to function dynamically and change the outcomes accordingly. The independent checker. So governance, as we talked about earlier, is is more around humans checking the outputs. But here we are talking about agents checking each other's output before it goes to human. Let me give you an example. This is a very relevant example, which we also use for our software development process. So as an example, we need to develop a piece of code for something as simple as login page, right? And there are specifications being put together on how login should work, or how the error messages needs to be handled, or the error situation needs to be handled. So the solver agent will look at the specifications and write the code. Then the proposer agent will go in, look at the specifications, look at the code, and build all the test cases which this code should pass before it can be considered as production ready. And then checker agent goes in, looks at the test cases developed by the proposer agent, and also any other system-wide, architecture-wide uh, assumptions which would have been added as part of software development. So it will have the specificity around the business requirement and any overarching requirements which the system should adhere to. And checker will take both of those and check the code which solver wrote. So essentially, there are three agents independent of each other checking each other's work. So again, we know running these agents can be expensive from time point of view, because if you keep checking everything, it adds to the delay, and of course, with the token cost, it adds to the costs. So we don't need to do this cross-checking in every scenario. As an example, if the information which user wants to know is a simple lookup, and agent is able to determine that the data it is looking at is latest and greatest, so it can just look up the information, provide the insight. However, if the information is looking at has passed the freshness threshold, then maybe it needs to double check with the system and ignore the cached information, pull the information from the backend system, and then provide insight. And but if there are multiple steps to a process like the one I gave you about software development, those steps need to be validated against multiple agents, and those do need thorough inspection before the output goes to the user. Okay, the anchor reinjection, and it's very likely you would have seen it while using Cloud or ChatGPT. As we go through the conversation with the agents, a lot of times it drifts. And now this drift is different than agent's performance drift, because drift can happen either because uh, the data surrounding the system has changed, or the use cases have changed, and that can impact the performance of the agent overall. Say, as an example, if the underlying formularies or policies have changed for a given agent, then it will start impacting the performance of the agent. So that's more of agent drift in terms of performance. Here we are talking within a single set of transactions, agent drifting from its goal. I'll explain with an example. So say customer chatting with the system, I say, I received this order and your product is damaged and here's the picture. And as an example, if the policy of the website clearly says that customer is returning the product in 30 days and provides a picture, you can process the refund. However, while agent is going through the process of refund, it's likely going to ask few more questions to the customer. Say, hey, can you confirm the order number? Or can you confirm the delivery address? Or do you want refund to be paid as store credit or back to your original payment method? So in all these cases, there are multiple steps happening, and agent is notating down all the inputs it's getting from the customer. So I'll put it in three different buckets of, say, working memory, where the task agent has on its hand right now. Okay, as an example, where the refund should go, or the address verification, and so forth. Then then we will put another bucket of memory. We call it as episodic memory, where all the notes which agents is taking based on what customer is telling. And then we have semantic memory, which would be all the facts, the policies and the guidelines against which the final decision has to be made. So as the agent is going through multiple steps, we need to make sure that we keep reinserting the final goal, which is to be which is the refund, and and all the criteria which needs to be met. So it doesn't forget what it needs to achieve at the end of the day. Now we'll talk about the resolution protocol. And just like in our day-to-day life, we see as human beings, when we work with larger teams or distributed teams, the biggest problem we run into for achieving success is around communication and coordination. And there are always conflicting schedules, conflicting priorities, and not bringing everybody's same page is always difficult. So our AI agents have exact same problem. In fact, coordination and communication among agents is considered to be the single most important aspect in a multiple agent setups. Uh, so here, agents are getting conflicting information from each other, or they're disagreeing with each other. And unless it's designed, they can get into this never-ending loop of trying to figure out what needs to be done. So this is one strategy or three-step strategy which can be implemented to uh, uh, manage this conflict, which is, if agents are not able to decide, define the bounds, if they are not able to decide in two, three, or four interaction, then a tiebreaker agent needs to come in, which will have defined rules of arbitration or orchestration to make a decision to move the whole system to the next step. And then we also need to make sure that the data which is being shared among the agents is versioned and time stamped, and there are clear rules defined to say how to resolve the situations and then communicate back to the agents. Uh, so apart from the rules which tiebreaker agent needs to use, there are other aspects which we can build in terms of the communication layer of the agents, and it could be around the schema of the information which agents share. So as an example, you force agents to declare the intent of their interaction, the input they have to provide to the other agent, and the expected output from the other agent. Other aspect here is explicit intent. So every message needs to have tags such as propose, critique, and refine. So when tiebreaker agent comes into picture, it knows how the information has flown through. And as much as possible, try to manage a single source of truth. And if it's not possible, at least have some kind of versioning and reconciliation process around the source of information. So now we jump to the approval gate. So last pattern which we talked about was around disagreement among the agents. In this case, there is no disagreement. And say, as an example, you have a refund agent and it goes in and its processes refund and everything is working fine. However, say in your situation, there is a problem with the downstream system. So all of a sudden, on a fine day, instead of or a typical day, say you have about 10 to 15 refund eligible orders, and today it happens to be 100 refund eligible orders. Just not because the agent did anything wrong, but because the downstream system had some problem. So there needs to be a process put in place whereby before, uh, so it's able to handle any downstream challenges. So as an example, that threshold could be based on the dollar value of refund. It could be based on number of refunds coming in a given day, or the frequency with which it's coming. So before it goes out of its normal cycle of processing refund, somebody is able to see that today is not a normal day because of some other issue which happens. In this case, not that agent is doing anything wrong, it just doesn't have the checks and balances in place to look for or figure out any downstream or maybe even upstream issues. So while we design this kind of system, we also need to be aware of the fact that if agent stops refunding in this example because all of a sudden it saw humongous number of refunds, human beings or the teams will not jump on attending the issue right then and there. So we need to build in the aspects of state persistence or saving the information. So as and when human beings do come in to look at the information, they are able the agent is able to provide all the insights to the reviewer, gives the complete picture as to why it felt what it felt in terms of stopping the processing. So human being can look at the complete picture and again restart the process if they deem fit. An agent is able to start from where it stopped rather than going from uh, zero again. So this is the QR code for S.O.N.G framework. It's available on our website. Takes you through a questionnaire, and I can jump to that in a bit, and I'll show you how easy it is to uh, figure out whether your AI implementation is S.O.N.G compliant or production ready or not. Uh, that's it. I think that's all I had, Jason. If you want, I can share song video right now.
Yeah, you were going. I pulled up your web page where you've got the song framework form to request a copy.
Oh, okay.
But if you want to demo something else, that'd be great.
Yeah. I'll just do a. Are you able to see my screen?
Yes, sir.
Okay. So of course it's on our health website, but the principles are applicable universally. So here it's just a quick wizard. So basically ask you a bunch of questions around how your data is being gathered. Uh, you know, Walks you through some 12 questions. These are all healthcare rate specific questions. How your API communication is happening. Uh, what is your escalation process or protocol in place, and how is it being made part of your workflows? I'll just quickly go through those. So it's going to measure the outcomes on all the four dimensions of, uh, oops. Okay, so here it came back with all the different dimensions along signal, orchestration, normalization, provided you insights, uh, steps you can take to improve your implementation essentially. That's all I have.
Terrific. Does anybody have any questions for Tushar? Please feel free to raise your hand. I can take you off of mute, or you can drop them right here in meeting chat.
No questions, Tushar, but I think you gave me a lot to think about. Obviously, in a lot of technical pre-sales conversations, discovery, kind of talking high level about solutions, not necessarily so much on your end. So things to keep in mind as I kind of set the stage for these types of projects, but I appreciate the thoroughness and all the examples along the way.
Thank you, Ashley.
Yeah, and I find it amazing that what you were talking about here on your site about this moment of convergence, where there's a compliance deadline coming up January 1st for healthcare organizations. Do you want to speak to that?
That's a totally different animal, Jason. It's about CMS regulations.
But I think it speaks to the need where like there are certain industries that are being driven down this and they're dry and so they're getting on board and they're going too fast and they're not taking the time to step back and look at a framework approach like you're showing so that they can get the value out of these. They're spending a lot of money on these pilots and they need to get the return of investment out of them, and they need a framework like yours to help them through.
sad thing is, this happened last week. We were talking to a prospect, and first thing they ask is how much will it cost and all this stuff, and had to go to the step of saying, okay, first of all, understand the various aspects of the cost. There's infrastructure cost, there's a build cost, there's a ongoing management cost. So there are these three parts of the cost, but I, I think that way to look at it is look at, are we able to 10x your investment over a period of time?
Mhm.
If you're not, then it's probably, and if you can't give a number or adoption scale for your investment, then it's likely project will not go anywhere.
Agreed. There has to be presence of mind to think forward of like not just what we're plopping down in terms of our cost and what we're getting out of it, but what it's setting up. Because there's the right approach will give a client the opportunity to build in the right direction. And the lowest cost, as we all know, being consultants on this line, is not always the best solution.
Yeah.
I'm going to throw out a last call to see if there's any questions here for Tushar or comments. Feel free to drop them in meeting chat. I always like to play the Jeopardy frame theme in my head, see if there's anything coming on. I don't hear anything, so hey, everybody, join me thanking so much Mr. Tushar Puri for coming by, sharing his expertise with us, and look for a recording that you can share out. Going out to LinkedIn. Thanks again to the IAMCP Southern California team for making this happen, of which Tushar is a secretary, he's a board member, and a fine contributor. Thanks, everybody, for your time. We'll see you again shortly.
Thank you. Have a good one. Thanks,
Thank you for
Tushar.
the opportunity, Jason and Ashley.
You got it.
Bye.
Bye.